Okay, we are going to look at chapter 4, section 4, the counting section. So the fundamental counting rule. So this is where we are finding all possible outcomes and then doing probability of getting that certain outcome. So the fundamental counting rule is we are going to multiply the number of outcomes for each event to find all the possible outcomes. So this is going to look like N1, so let's say rolling a die, you have two possible outcomes there. N2, let's say our next event is spinning a spinner, all the possible outcomes for that, times, let's say, N3, all the possible outcomes of picking a card from a deck of cards. So you'd multiply all of those to get all possible outcomes. So this is like what we did with, let's look back a little bit. Oh, with the appetizers, entrees, desserts, we could have just multiplied to find all the possible outcomes. So let's look at example 1. To win a given lottery, you must choose 4 digits, 0 to 9, and repetitions are allowed. How many different lottery numbers are possible? So you are picking 4 digits. So we have 1, 2, 3, 4 digits. And you get to pick numbers between 0 and 9. And so that's a total of 10 possible outcomes for each one of these digits. So 10 possible for the first one, 10 possible for the second one, 10 possible for the third, 10 possible for the fourth. Because it says repetitions are allowed. So this comes out to, I'm going to do scientific notation or exponent notation, 10 to the 4th, which is 1 with 10 zeros, right? I mean 4 zeros? I don't know what I'm thinking. Great. So there's 10,000 possible outcomes. Example 2, assume a criminal is found using your social security number and claims all the digits were randomly generated. What's the probability of getting your social security number when randomly generating 9 digits? So the digits can be repeated. So you have 1, 2, 3. Does anybody remember their social security number? Do y'all keep it in your head? I have mine memorized. Huh? No, do not say it. No. No, do not say it. So it looks like that, right? So there are between 0 and 9. You can put in each one of these spots. So it's a choice. So there's 10 for each spot. So it's very similar to the last one, but this time we have 9 spots to fill. So we are multiplying all these outcomes to get how many options are there, how many different combinations. So that's 10 to the 9th power. So it's a 1 with 9 zeros. I'm not going to write it out. But then the probability of getting my unique social security number is 1 out of that. Because order matters on your social security number. I could have the exact same numbers as someone else, but if they're not in the right order, it's not the same. So we're going to talk about how order matters and how order doesn't with different kinds of outcomes. Example 3, you are in charge of planning an evacuation plan out of your office building. If there are 2 ways to exit your office on the 2nd floor and 5 ways to exit the building from the 1st floor, how many different evacuation routes are there? So from 2nd floor, we have 2 ways. And to exit the building from the 1st floor, we have 5 ways. So there are 10 total evacuation routes possible. So in case one is blocked, you can go a different way. The factorial rule. So a factorial is an exclamation mark. Like a exclamation mark. That's a factorial. I'm going to show you what that means. So it is the number of different arrangements of indifferent items when all items are selected. So it's finding out how many different arrangements there are. And you can't, and this is without repetition, because if I have, let's say 5 roses and I'm selecting 5 guys to give those to, like you think about the order, what order can you select? Like The Bachelor, what order can they select? So this is how you would do that. So this is 4 factorial. So 4 factorial means 4 times 3 times 2 times 1. You're multiplying each descending number, all the positive descending numbers, all the way down to 1. So 4 times 3 is 12, times 2 is 24, times 1 is still 24. So if you choose 4, now you only have 3 left to choose from. After you choose that one, you have 2 left to choose from. After you choose that one, you only have 1 left to choose from. So there's 24 possible outcomes. A 0 factorial is just 1. So an example of this would be, let's say you're going to Disney and you want to ride certain rides, but you can ride those rides in any order you choose. So you can use factorial to represent that instead of listing them all out. So let's think about how we could list these out, like Space Mountain, Tower of Terror, Rock and Roll Roller Coaster, Mission Space, Dinosaur. So imagine listing all of those out. And it's asking how many different routes are possible. So we have the same exact options. We are just putting them in different orders. So a way that we could set this up is using factorials. So we have 5 rides. We're using or going to each one of these rides. We just have different orders that we can choose. So we'll do 5 factorial. So you have 5 and you're choosing the 5. You're choosing all of them. You don't have to narrow it down. You don't have to skip any. You're choosing all 5. So this means we're going to do 5 times 4 times 3 times 2 times 1. All right, so go ahead and multiply that out. We can use our calculator. $120. All right. So 120 different routes available. All right, you're in charge of organizing the science projects for this week's science fair. If there are 12 different projects, how many ways could these projects be arranged? So 12 different projects, all the different arrangements. So it'll be 12 factorial. Don't y'all wish there was an easier way to do this? There is the calculator. So I'm going to show y'all right here. I won't torture you anymore. I'll show you the trick. So it says math, probability, 4 is the factorial. So go ahead and put in your number. So 12. And then we want the factorial. So go to the math button. I got a glare there. Over to probability. Down to number 4, which is the factorial. Enter. Wow. $479,000,000, right? 1,600. Yeah. Example 3, you delivered newspapers as a part-time job. If you have 8 houses to deliver the paper to before school, how many different routes are possible? So you got to deliver all of them, but you can go any way you choose. So 8 factorial. $40,320. Different routes. A routing problem is often referred to as the traveling salesman problem because they are important to see many different companies and the number of routes can be very large. All right, so that tells you the calculator. So if you want to make sure that you remember that. All right, permutations. When items are all different. So you are going to do different sequences. Without all options, all items. So you could choose to skip a couple. So let's say we have 50 capitals and we only want to choose 2 of them. How many different outcomes could there be if we choose 2 out of the 50? So this is what's called a permutation. So an important thing to remember about permutation is that position matters. The order matters. So permutation, something to remember is position, which means order matters. So let's say we're randomly picking 2 people to be president and vice president. The first one that we pick is president. The second one we pick is vice president. That matters, right? Because it's who's president, who's vice president. If you flip-flop them, that's a different outcome. So if you think about it as, let's say, ABC is not the same as CBA. Order matters. And we're not replacing them either. So they're in different items available. Select R. So it's like I have in and I'm choosing R. Have in items. Choose R items. Permutations, arrangements, and sequences are all considered rearrangements of the same items to be different. So the formula is n factorial over n minus r factorial. We must conduct surveys in state capitals, but only have time to visit 4 capitals. How many possible routes are there? So how many capitals do we have to choose from? 50. And how many are we choosing? Okay. So we're going to plug it into the formula. Before we put it in the calculator, I'm going to show you how you can simplify your fraction first. So n factorial, so that'd be 50 factorial over 50 minus 4 factorial. Let me show you how to break it down, okay? So stay with me. So we have 50 factorial over 46 factorial. But there's more. We can simplify it even more. Because 50 factorial could also be written as 50 times 49 times 48 times 47 times 46. And I'm going to stop there and just put a factorial to represent the rest of it. So I simplified the top so that I could simplify the fraction. So see how we have 46 factorial on top and bottom now? So that is able to simplify down. And now all we have left is 50 times 49 times 48 times 47. So that would be super helpful if we didn't have a calculator that had the factorial on it. So we can do it any of these ways. This is just one way of breaking it down further to make it a little bit simpler. So go ahead and put that in your calculator. $5,527,200. Okay, so that's all the total outcomes. It's a lot. All right, so let's do one more problem for this part. We must hand out fundraiser information to 10 senior homerooms, but only 4 homeroom representatives available today, but only have those. How many possible routes are available? So how many items or how many rooms do we have to go to? 10. And how many are we choosing? 4. And so the order matters because you're going to follow a certain route. So think about the route. That word route will tell you, is it the permutation? Does order matter? Yes. So n factorial and then n minus r. So I'm plugging in the 10 and the 4. So it's 10 factorial over 6 factorial, which we can break it down. 10 times 9 times 8 times 7 times 6 factorial. So I stopped at 6 so that I could simplify that 6 factorial out. And that just leaves us with 10 times 9 times 8 times 7. So this is, what, 5,000, what?
54.
Yeah. Oh, and I have a calculator trick for y'all too. Let me tell you all the calculator trick. So it's right here. It tells you. So see, we're going to same thing, math, probability. This time we're going to go to 2. See how it says NPR? P stands for the permutation or position matters. So we can do like example 1, where N was 50 and R was 4. So let me show you how it works in the calculator. Clear it. Put math over to probability. Down to number 2. NPR. Plug in 50 for N and 4 for R. Is it the same thing?
I did it on those two.
Do it.
I said I did it on the 10 and 4.
Okay. Awesome. Yeah, so we go ahead and do that. 10 and 4. So just remember that P stands for permutation or position matters. Order matters. We are going to do the other one, which is combinations, tomorrow. Okay, so we're going to take a break on this. So we're breaking this up into two different parts.